All right. Today we're going to dive into the prologue of artificial intelligence. Wait, or is that prologue? With a G?
Okay, so let's get this straight. You've got Prolog, which, kicks off a story. But then you have Prolog, short for programming in logic. And this language didn't just kick off a story, it kicked off a whole new way of talking to computers. It was one of the very first languages designed not just to follow our commands, but to actually try and understand our words.
And this whole story starts with a really specific challenge. See, back in the early 1970s, the goal wasn't just to make computers faster calculators. No, researchers were trying to make them, well, understand. The dream was to feed a computer a sentence in, say, plain French, and have it make logical sense of it. And that quest is exactly what led to the birth of Prolog.
This quote just nails it. It perfectly captures the two big ideas that had to come together to make this happen. First, you've got natural language processing, the NLP part, which is all about teaching computers to understand human language. Then you combine that with automated theorem proving. Think of that as teaching a machine to be a detective, right? Using a set of logical rules to figure out if something's true or false. Prolog was the mashup of these two really powerful ideas.
So how in the world did they make this combination actually work? Well, Prolog brought this totally revolutionary way of thinking about programming to the table. It literally took the idea of an algorithm and just split it right down the middle.
And that brings us to this incredibly powerful idea from Robert Kowalski. An algorithm is just logic plus control. So the logic is the what. What's the problem you're actually trying to solve? And the control is the how, the nitty-gritty steps you take to solve it. Now, most programming languages just jam those two things together. But Prolog pulled them apart.
Think about it like a recipe. The logic, that's your ingredient list and the beautiful photo of the finished cake. It tells you what you want to make. The control, that's the step-by-step instructions. Preheat the oven, mix the flour, you know the drill. That's the how. The absolute genius of Prolog was that it let programmers focus only on the logic. You describe the problem and the end goal, and the language itself figures out the control. So how does Prolog actually figure all this stuff out on its own? This is where it gets really, really clever. It uses those logical rules you give it to explore every possible solution, and it has this unique way of going about it. Just take a look at this. This is a parse tree, and it shows how Prolog can digest the structure of a sentence, breaking it down into all its grammatical bits and pieces. It's kind of like diagramming a sentence back in school, right? It sees a noun phrase, the man, and a verb phrase, bites the dog, and it knows how they fit together. And here's the kicker. The programmer's job isn't to build this whole complicated machine. You just have to feed it the rules. You give it a simple, clear rule like this one here. A sentence is a noun phrase followed by a verb phrase. You just describe the logical facts of the world, and Prolog does all the heavy lifting. But okay, what if it tries to parse a bunch of words as a noun phrase, and it turns out to be wrong? Does the whole thing just crash and burn? Nope. And this is where Prolog's automatic control system, this amazing process called backtracking, kicks in. Backtracking is Prolog's secret weapon. Seriously, it's like you're solving a maze. When you hit a dead end, you don't just stand there and give up. You automatically go back to the last place you made a choice and you try a different path. Prolog never, ever gives up after just one failure. It automatically explores every single possible path until it finds a solution that works. This example just shows it perfectly. Let's say you want to find Tom's grandmother. Prolog first tries rule number 1, the maternal grandmother. Okay, it finds Tom's mom. Her name's Judy, but then it looks for her mother and comes up with nothing. Dead end. So what does it do? It backtracks. It completely throws out that first rule and tries the next one, the paternal grandmother. It finds Tom's dad, Dick, and then it finds Dick's mother, Mary. Bingo, success. And the key is this all happens automatically, behind the scenes.
Okay, so knowing grammar is great, but it's not enough to really understand language, right? A sentence can be perfectly put together and still be total nonsense. So let's see how Prolog makes the jump from just structure to actual meaning.
This is a huge leap. We're going from syntax to semantics. So we're moving from just checking if a sentence is built correctly to figuring out what it actually means. Grammatically, the man bites the dog is totally fine. But does it make sense? Is it plausible? This is that whole next layer of understanding. So this is how Prolog starts to wrap its head around meaning.
Instead of just seeing a string of words, it builds what's called a conceptual graph. It's like a map of the relationships. For the action gave, it identifies Mary as the agent, the book as the object, and John as the recipient. It's literally mapping out the role that every piece of the sentence plays.
And it does this using something called a case frame. It's pretty cool. For any verb, you can define a frame that lays out some common sense rules. So for the verb bite, you can create a rule that says the agent, the one doing the biting, is typically, a dog or some kind of animal.
So now, when Prolog looks at the man bites Fido, it checks its case frame for bites. It sees the agent as a man, and it says, wait a minute, that doesn't fit my rule that the biter should be an animal. The grammar is perfect, but the meaning fails the common sense test. And so, the system just answers no. I mean, that is a huge step toward genuine, real, natural language understanding.
Now, remember, this was all happening way back in the 1970s. So the big question is, why does this old logic-based language still matter today? In a world that's all about neural networks and huge data sets.
Well, Prolog's influence is absolutely massive, even if you don't write in it every day. Its core ideas have shaped how we tackle all kinds of complex problems in AI. I mean, it kicked off the entire field of logic programming. Its parsing methods were fundamental for modern NLP. And maybe most important of all, it proved how incredibly valuable it is to separate the what from the how, an idea that still influences how we design software to this day.
And that really is the mind-bending thought that Prolog leaves us with. If we just focus on defining the rules of the world, the logic, and leave the how entirely up to the machine, we open the door for it to find solutions and pathways we could never have imagined ourselves. It's a powerful reminder that sometimes the best way to solve a really hard problem is to describe it perfectly and then just get out of the way.